I would like to present a second speaker, Vadzim Zubovich. He is a QA automation engineer, and he will talk about proper QA automation. Please welcome him. Thank you.
Hello, everyone. Whoa, that's loud. Okay, so my topic today, I've actually found out that there was a small misprint in the program. It's living on crutches, not crotches. So if you were expecting to see some explicit content, there won't be any, so you can leave. Well, let's go ahead. I will speak about anti-patterns in UI automation. And let's begin with my introduction. I actually am a colleague of previous speaker, Roman. We work in the same company in EPAM in Minsk. It's the biggest IT company in Belarus, and well, it is kind of big in the whole world. I play the role of QA automation tech lead, team lead, and resource manager. Basically, being responsible for the processes in QA automation is part of my job. So let's begin with the question, why crutches? There is a well-known term in IT, in coding, basically, crutches. I think you know about it, don't you? Anyone familiar with this term? So, awesome, one person. So for the rest of you, I'll explain briefly. So a crutch is some quick fix that doesn't really solve the problem, but allows your system to function as expected. And why did I call the topic living on crutches? Why crutches? Well, if you look at the description of what anti-pattern is, you will see that basically these are the same things, because anti-pattern is the very common approach that is often used that does not really solve the problem, does not fix the problem itself, but fixes some consequences, thus allowing it to function as expected. But it can have a negative output in the long run, and we'll get down to this right now. So why living on crutches, not just, well, having crutches for a while, but living on them? Let's compare how crutches work in real life. You know that you have them for a while, and then you can walk again as you used to. But in coding, when you start using crutches, when time goes on, you just add up more crutches and more. And you may end up with one sticking up your, well, and it is painful, so that's why I started this talk. I will be speaking about a lot of very obvious things that everybody knows, or most of people know, so there may be a reasonable question, why do I speak about it? And there are several answers. The first one is, I'll explain it a little bit. There is a very good, well, not saying, but expression, rather, in Russian language, to step on the same rake, which basically means to make the same mistake over and over again. And, well, you know how it goes, something like this. So even though most of people know about the common anti-patterns in QA automation, most of people still step on this same rake. And it's okay if rake is like this, much worse when it's like this. The second reason is if you follow all the rules that I mentioned here, so if you use all the anti-patterns I mentioned, you will end up having a lot of fires on your projects that you will have to deal with. You will have to fix something really urgently and, well, not permanently, unfortunately. And it's okay if they are like that, but if your project starts burning whole, you'll be in a lot of trouble. And the third reason why I speak about it is you can actually think up pretty funny names for the anti-patterns. Yeah. Someone gets the pun. Okay, so I will divide the anti-patterns I'm speaking about in 3 general levels. The first one is organizational anti-patterns. When you actually approach the whole testing process the wrong way. They do not have anything to do with the code itself, but the whole process, when you start it the wrong way, it goes the wrong way. The second group is the architectural anti-patterns, which are the anti-patterns in QA automation architecture in general, when your solution has some disabilities due to wrong decisions. And I need to comment on this picture. Actually, when last time I spoke on this topic in Moscow, we were taking a walk around in a park, and we saw this beautiful construction, which is a playground for basketball. And if you are familiar with any type of rules of basketball, you can see that, well, there's something wrong with the grass field. And I have to comment, it's not very well seen on this picture, but none of these baskets are in line. So they are moved against one another. So actually, you can play, for example, street ball with this, even on the grass, which is bad, but you can still do it. But you cannot expand this solution and play basketball with normal rules. So that's the good example that I ran into before the talk on this topic, well, of the architectural anti-pattern in practice. And the third group are the development anti-patterns, which are often called code stinks. That explains the picture. And let's move on. So I will need some input from you. What do you think? What's the first anti-pattern? And I will comment, it's actually out of the scope of the previous ones. Any guesses? Nah, you won't guess. I'm just using you because, well, the main anti-pattern is to consider all the anti-patterns to be complete evil. So even though I'm speaking on this subject and I'm pointing out how bad it is to use anti-patterns, there are some cases when they can work well for you, work well for your project, and well, be some kind of time economy. So even though I'm saying that it's bad, it's not the absolute evil. Sometimes you just have to put your brain to it, and you may apply them. So just don't take it too seriously. So the first and most common organizational anti-patterns are the testing pyramid anti-patterns. And there are the 2 most common ones. The first one is known as ice cream cone. When we have the small amount of unit tests below here, slightly bigger amount of API tests, then we have a big number of UI automated tests, and on top of this, huge amount of manual testing. And the second one is the cupcake anti-pattern. When we have huge number of everything. So we have a lot of unit tests, a lot of API tests, a lot of UI automation, and a whole lot of manual testing on top. So let's speak about them. First of all, the first question, okay, so we have small amount of unit tests, we have UI automation, we have manual testing, so what's so bad about it? And the point is that we have a very small amount of the most reliable and fastest tests, which are unit tests. We have huge number of the most fragile and optimizing and demanding tests, which are UI automated tests. This level is huge, so you have to do a lot of work to support them. And we have a whole lot of manual testing. So what's the point in automation then if we're still doing huge numbers of manual tests? And let's get to the answer to the question where it comes from. Well, first of all, it's seemingly difficult to find resources to write unit tests. It's seemingly difficult to create the special environments to run unit tests, to set them up, to create mocks, etc., etc. So this seems like a separate, huge task, so just people don't take it at all from the very start of the project. The second reason is that, well, as you know, unit tests are usually written by developers. That's the normal case. And most time, developers are busy with some current tasks, and they have no time for unit testing, so they say, okay, we will not do this now, we will probably find time later, etc., etc. So we have this small amount of unit tests, and on top of that, we have to build up a bigger amount of API tests and even bigger amount of UI automated tests, because we don't have all the features tested during the unit testing. Same questions for the Cupcake. So the problem here is that our UI tests actually cover the same things that are already covered by unit tests, and manual testing covers everything that's covered already by automated tests. So this is not an optimal way to build up your project structure, because the work is doubled a lot, and you spend a lot of time on testing and verifying the same things, which actually costs money. Where it comes from is generally, first of all, when automation engineers don't have any certain testing plan or testing strategy, they just write tests for whatever they think they should write tests. They do not communicate with developers or manual testers, so they automate everything. And here we double our work on each stage. So what should we do? What's the right way? Once again, everybody knows how the testing pyramid should look like, but I've seen very few projects where it is like this. So we should have the huge amount of unit tests that covers most of the basic non-interaction tests. Then we have slightly smaller amount of API tests. Then small amount of UI automated tests. Basically, usually they should be the walkthrough scenarios and the common overall application tests, not just the basic separate button test or something like this. And on top of that, the best part for manual testing is exploratory testing. So we leave this in the clouds somewhere up there. The next anti-pattern, I call it fast and furious, and here's why. So let's imagine the situation when a customer comes to us and says, we want to have test automation. And I think the thing I'm going to describe is familiar to a lot of you, probably to all. What we do is we're off. We start writing the testing framework, writing tests one by one till we have hundreds, and we're happy with it. We're attaching some reporting framework. It's working perfectly. But the issue with this approach is, and I will ask you another question right now, let's look at this from another angle. What does the customer want when he says we want automation? Any guesses? Quality. That's a good answer. Not exactly, because quality can be achieved with manual testing. When they say we're not happy with manual testing, we want automation, they do not want the testing framework. They do not want the testing reports. They do not want anything that we have created for them on this initial stage. They want the testing process to be faster, usually. Basically, the main reason why it could be fast is by speeding up the regression testing. Mostly that's the biggest use case for automated testing. So this is what they want, and this is what they get. Because they do have a very nice test automation solution, your project, very nice reports, but do they actually function as the speed up for your testing process? No, they don't. Just as this door, it's standing in the middle of a field, it is there. You have done some beautiful, magnificent work, but it doesn't perform as it should be, because you can walk around it anytime. How come? Well, basically, that's because your tests, your automated tests, perform for automated engineers. So the results are analyzed by you, only you understand what they do. You do not have any documentation whatsoever, no test plan. So reports tell some information only to the automation engineers. The manual testers will not reduce the scope of manual testing because they have no idea what your automated test does. The developers will not work on unit tests, more or less depending on what you have tested, because once again, your reports will tell nothing to them. Will they analyze the defects from your reports? Probably not. So if you do not send exact information to developers, they will also not work on them. So this will not work in this fashion. So what should you do is start with planning. Organize with other teams, with manual team, with developer teams, coordinate with them, and work on some overall document that will work for all of you, and that will tell them all what you have tested, which results mean, etc., etc. So you need to start with documentation. I know that usually people don't like to work on it, but without it, you will end up with the door in the middle of a field. The next one, I call it stay positive, bro, which is, well, I think it speaks for itself when you have only positive test scenarios. Why does this happen? Well, first of all, it's because, once again, lack of definite planning. So when you start automating tests just without any certain plan, what you think about first are the positive scenarios. When you cover them, you may end up happy and thinking that you've done something cool, but you leave a lot of things out of scope. The second reason is when an automation engineer is former, for example, developer, he has that kind of developer mindset when he supposes that, well, the application should work this way and I will test it. So this will mean that it does work this way and everything is okay. And you will not test what happens when something goes wrong. And the third reason is just when you have the specs and when designing your tests, you just follow what is said in the specs. For example, field number 1 should accept not more than 1,000 symbols. So you enter not more than 1,000 symbols, just like in the specs, and you think you're okay with it. The problem with this is pretty obvious, I think. But once again, a lot of people, especially newcomers, make this mistake. So the problem is that the huge amount of testing and the most useful testing actually stays out of scope. The right way is to stay a bit negative and pessimistic and expect that the application will work under conditions that are, well, not common and not actually mentioned in the specs. The next one is a mixture of architectural and processual patterns, which is, I've called it Breaknig B.DDI. Does anyone get the pun? I've made the A letter smaller so that you can see the BDD there. And I want to point out that from the very start, because I often get this question, I am not against behavior-driven development. It's a very good concept. It works perfectly, but it works perfectly only when cooked well. So what happens oftentimes, and this is what I'm speaking about here, is that we just use some tool for BDD like Cucumber or SpecFlow for C# or whatever else, JBehave in Java. We write scenarios in Cucumber, in Gherkin language, and we suppose that, well, okay, we have BDD, we're cool. And why does this happen? The first thing is, it's kind of cool right now, it's in trend. Everyone is speaking about BDD, and the next argument is just the killer of all arguments that is always brought up. Anyone can write automated tests with BDD, even stakeholders. But the key word here is can, not will. Because I've never seen that the stakeholders would take part in the actual tests design and writing. They may take a look at your final results. They may suggest something, but they will never write them. Even the manual QAs usually do not take this idea very welcoming because they have their work to do, and if they are used to design test scenarios in a different way, they will not embrace this very easily. So, what issues we have here with implementing this approach this way? This is basically our automation engineer who will, right now, aside from designing the automated tests themselves using the programming language like Java, C#, whatever, Ruby, they will also have to write additional layer that will be responsible for connecting the Gherkin scenarios with the actual steps in your code. So this will be the extra work, and it is a lot of work, believe me. And once again, pointing out, I'm not against BDD, because in certain cases, it provides a lot of benefit, but it needs to be cooked right. So the right way is basically to implement the whole process of behavior-driven development. It's called behavior-driven development for a reason. It's not behavior-driven testing. It's behavior-driven development. So it means that we need to build the whole process of development, not only testing according to this. So we need to start with writing scenarios, then implementing features according to these scenarios, and then follow the TDD rules by running tests beforehand even. So the red-green refactor approach, so-called. So if you do it this way, if you follow the whole process, this may have benefits. And I have talked to a lot of guys who told me, hey, well, why are you so bad about BDD? We have it running, it's absolutely awesome. But once again, you need to do it right, then it will work. If no, then you will simply end up with spending more time on things you don't need. So think twice before you actually implement BDD. Start with thinking, why do you need this? Which problems will it solve? And how will it solve it? Not just, hey, BDD, it's cool, let's use it. The stakeholders will write our automated tests. No way. So think twice. The next one I've called Rube Goldberg machine. Anyone familiar with that term? Actually, the Rube Goldberg machine is something very common. We've seen it in a lot of cartoons and on YouTube. It's some machine that does a lot of complicated work to end up with performing some very simple task. Like in this case, the ball runs all around and then in the end it will just push some button to make a cup of coffee or something like this. So basically it's about having a too complex solution for automation, implementation. The same thing I have said with the first 3 words can be said with 6 words, and it does not make it better. So the same thing applies to code. Having a lot of code, having a lot of complicated classes in your solution does not make it better. So this is the live example from the actual project, where we have certain things that still cause a lot of questions from my end. Why do we need to have the web driver initializer here, the web element initializers, the wrappers for each type of element? Is this really that necessary? Did we really start with thinking, well, we will use clickable for this and that? Why? So every time when you try to make your solution more complex, ask yourself a question. Does this really make sense? So this anti-pattern comes from basically 2 sources. The first one is when the automation engineer has the strong need to perform as the architect, because he has studied object-oriented programming. What for? I need to design a solution that will make me proud. So I will write like 10, 15 classes with interfaces, with anything, and that will be cool. It won't. It will only complicate things. The next reason is also a very common one when the automation solution is designed by the architect in development. And these are usually the worst cases. Because architects always think that, well, architecture should be huge, very well thought, etc., etc. We don't need this for automated tests. Actually, I always try to avoid the word testing framework when we talk about building up the automation solution, because it's not the framework we're building, it's the automated solution or project, wherever, but not framework. The frameworks are specific tools that are designed to make automation easier, but they are not the tests themselves. So a simple solution does not really need a complex architecture. And you will end up with a mess like this in the end, which is not supportable. And here I suggest having a very quick test for your solution. If you just call any junior automation engineer to your project and give him the task, write one very basic, very simple automated a test for our project. If he does this in like 15 minutes, then your solution is perfect. If it takes him hours to dig into that and search for a WebDriver initializer, then figure how it is connected to the WebDriver container, then initialize web elements using this separate class, then it's a piece of garbage that will basically look like this in a while. The easy entry point is basically the key to success in automation. So things should be done as simple as possible, but not simpler than that. The next antipattern is the pure coding antipattern, which I call what if. You are probably also familiar with it. This is also the live example from the actual project, and I will explain a little bit here. So we have a test that needs to check whether the table with data is shown on our page. Actually, if we have some data in our database, then the table appears on the page. If we don't have any data, a special message that says, sorry, no data, appears instead of the table, so there is no table. And what this test does is it actually, as you can see, it checks if the table exists, then it will check the contents of the table. If there is no table, it will check that the correct message is here. So what seems to be the problem once again? What's wrong with that? Sorry, let's start with reasons of this. So the first reason is trying to reduce the number of tests, which sometimes seems like a good thing for a lot of people who combine a lot of tests into one. And the second reason is, well, it is checking, right? It checks if the table exists, then it checks the contents. If it doesn't, then it checks the message. Or the third reason is, well, I cannot do it any other way because I do not know if the table contains any data or not. So what shall I do? This is how I deal with it. So the problem here is, first of all, let's take a look what our report will look like on this test. This is one version of the report, and this is the other. Are we sure which one of these checks was performed here? I don't think so. Do we know if we have checked both versions at all? I don't think so. More than that, we are not checking both of them during one test run. And this is basically the second problem with it. That it is possible that during our multiple test runs, we will still end up with checking only one path, and there will still be a separate part of functionality that will not be checked at all, just because we have used that if statement once. So what should we do? We should first of all split these tests, so we should check if the table has correct data and check if there is a correct message if we don't have the table. And the way we do that is by preparing the actual conditions for both scenarios. So we need to create the preconditions so that we don't have any data, and then check that the message is correct. And then we need to create some data, edit there, and check that the table has correct output. The next one, also pure coding anti-pattern, is hardcode everywhere. It comes in several variations. The most common ones are hard-coded data in our tests. For example, we may hard-code the user data like username and password. And it looks okay. Once again, not always obvious issue here. Well, we know what user is, what he does, what we need them for. But in case your projects live long enough, hopefully, you may end up forgetting yourself what this user is responsible for, what kind of user it is. And if you have to recreate them, you will not be sure, okay, this is user 2, what was the user 2 access rights or anything, so how we will recreate them. And there are oftentimes cases when people change on the project. So you may forget it yourself, and what about other people who will join it? They will have no idea what this user is and what this scenario is for. So the right way would be to at least use variables that will speak for themselves. Like in this case, this is a valid user with edit access. So you can read the variable name and you will be sure what kind of user you will need to recreate and what this user does. So in the end, you will just use these variables in your tests. It's always a good practice to keep all this data in a separate file. So this is just one of the examples. You can use XML, JSON files, or anything else for that matter. The second version is hard coding the configurations, like when we have to run our tests in different browsers. Well, in the beginning of the project, you can just stick with one of them, just use Chrome. So you hard code Chrome driver initialization in your project. And also you hard code the application URL, which is fine on the very first stages. But if you're expecting your project to grow, probably there will be more URLs. Probably you will need to test it in more browsers. So it's always better to configure your solution. This is the command line argument example for Maven project in Java, where you can actually configure it from the command line. So you can just send the Firefox argument and your solution will process it and will run tests in Firefox. Or you can also configure anything else like the URL or any other extra configs. Why it's better to use command line arguments? Because it's easier to use them when using CI tools like Jenkins or TeamCity or TFS, whatever. It's very easy to use command line arguments to modify the test execution from there. Or at least you could just use some config files like XMLs, once again, JSONs or anything else. It's also a nice approach. Command line is better because it's easier to use, as I've mentioned, from CI. But this is anyway better than hard code. The next one is something broken. I will just show you once again the example and you will immediately understand what's going on here. So we have the error message that says expected true, actual false. Does this tell a lot about what went wrong in our test? Anyone? Any mediums here or people with extrasensoric senses? Maybe, but I will tell you this, actually. If you need to dig into the logs or anything else to analyze your test results, this means one of two things. Either your reports suck, sorry, or your tests do. So you will need to modify any of them. So because the perfect report is the one that tells you immediately, just by a glance, what went wrong and how to fix it. So the better way here, yeah, well, that's where it comes from. I think it's obvious. So what we should do here is at least add the custom error messages to any of our assert true or assert false statements, which can be kind of time demanding, time consuming, because you will need to write them for each of the cases. Or you could use some matchers like Hamcrest matcher in Java, which is awesome, where you can actually configure the general skeleton for the error messages, and whenever you use this sentence here, you will automatically get the message that the username is not visible, for example. So this will tell you immediately what's wrong with your tests without looking into the logs, without looking at the screenshots or whatever. You will not have to click this test in your report to see what's wrong in there. And that's the perfect approach. So that's it from my end.